Here we are. Welcome to the Headwaters Science Center. Some of you historical enthusiasts may know what special day this is. This is Gerard's birthday. Yes! And it's also the Headwaters Science Center birthday. So you were born on the day that we were born as well, 27 years ago. So we are 27 years old. How old are you?
7.
6, now 7, right? So you're officially going to be 7. Is that today?
Yes.
You are 7. Okay, so you're going to celebrate your birthday moment, perhaps. Well, maybe you know, there's been a thing going around, and people haven't been going to parties like they once did. And we haven't held a party in near a year now. So we decided that we were not going to let Jorah's birthday go by and not have a party for it and celebrate for ourselves as well. So we're going to tell you some of the things we would do if you came to our place and had your party here. So what we like to do is bring our animals into the story. Why don't you bring some of those animals forth? Let's see what we have here. What do you guys have? See, I didn't know that was coming first. I thought this was going first. Bring them in. Show them what we have. What do you have there?
This is Leo, our bearded dragon.
I call him Scorch. And you can tell us about him. Tell more about him. Where's he from? He's from Australia. He's from down under where it is summertime right now. And he's quite a feller. He's been with us for about, 3 years now, 4 years?
About 2.
Yeah, Leo has metabolic bone disease.
He does?
No, that's true.
Or
I don't think
Ellie
that's true.
constantly says it.
Ellie, I think you're wrong about that. He has a fat belly is all he has. He's been fed and loved too much. Well, what do you have there?
This is Hypatia, the blue-tongued skink.
Does it really have a blue tongue? Can you tickle the blue? There it was. I saw it. Did we see it? Did the camera see it? Bring that tongue right in front of the camera and see if we can't tickle out a blue tongue. Why would you want a blue tongue?
A little scratch under the chin. See,
Give it a little stimulation there.
You see here.
You get a blue shot?
It'll stand out good against that shirt too.
All right, so this animal has a blue tongue, and the true reason is we don't really know why, but we think that a blue tongue is something that might scare a predator away to go, I don't do anything with blue tongues. Blue tongues I avoid. So that's sort of maybe what it is. And that's one of the things I really love about science. When you don't know something, you can guess at it and then try to prove it. And then maybe, who knows, you convince your colleagues and publish yourself in a journal and become famous and something gets named after you. All right, where we have it? What else? Whoa, what do you have there?
Ball python.
A ball python. I'm noticing something about your ball python here. It has little scary alien creatures on there. Is that an alien portrait?
No idea.
No idea? Well, again, one of those, what's the idea of that? Can they go show the camera some of those little alien scary faces. So I believe that those alien scary faces on that critter helps it protect it from predators again. And they go, where's the head on that creature? So maybe that would lead to success in breeding. Your children would have similar markings along it, and so perhaps you could survive better. So there's the ball python. What do you have, Al?
I have Amanda.
Oh, our sweetheart with the soft soul, the Egyptian. Her name is also Morocco. The spiny tail. She's a sun worshiper, glorified in the Egyptian kingdom. Found actually on the pyramids. Don't keep her out too long, you know.
Okay.
She's a beauty. She's got a real soft soul, though. Show the camera. Show the camera. Show her what we have. Don't let her jump. And what her routine is that when she's ready to go to sleep or to go into her private home, which she does a lot, she sleeps in late. That's just her nature. She'll go in and have her tail at the door, and if anything bothers her, she'll whip that tail at you and get out of here, get out of here. She's a total vegetarian, and she's one of my favorite creatures here. Whoa! Looks like we're creaturing up here a little bit. What do you have there?
This is Rusty, the red-tailed boa constrictor.
Red-tailed boas are from South America.
Yeah.
Yeah, and we'll find them up into Central America too. So this is our male boa constrictor. Its scientific name is also its common name, boa constrictor. And what does that mean, constrict? Is it constricting you?
Nope.
Are you worried it's going to
No.
eat you or choke you with its constricting?
I'm much too big for him to eat.
Much too big to be eaten by this snake. And Ryan taught me something today, and that is they can eat a creature about as big as the widest part in them. So that's wider than its mouth. So it can really open its face up and put a creature down into it. All right, well, those are some of our animals that you might find if you had an animal party here at the Headwaters Science Center. We do dino parties, and while this isn't a dinosaur, we do have something inside of it. But one of the other parties we're known for doing is sort of this mad scientist thing. And we're not really that mad, we're just a little bit crazy. So one of the things we like to do is experiment with matter and strange things that act in different ways. Like for instance this stuff right here. Well, it looks clear, pours like water, doesn't seem to be acting like water, does it? Pour it all out there. Got something I need for that. All right, so I've got that in here, and it won't last very long, so we're going to get right at it. Let's look at this stuff. Okay. Good, I couldn't even tell my glasses were on. That's good. All right, so I'm going to pull some of that out of there. First of all, take this, put that in there, and we're going to see that doing that. What is that it's doing? What's it doing? It's boiling. The heat is boiling. And I'm going to tell you that this is minus 321 degrees below zero, and it's boiling. So I'm sure somewhere in your brains, you made up the idea that boiling belongs next to hot. Well, it sort of does, it sort of doesn't. What is boiling helps me realize what's going on. Boiling is changing state, and that doesn't mean we're going over to North Dakota or Wisconsin today. It means we're going from a liquid to what? What does it become? What does it become? When it becomes like air, it becomes a gas. So this is moving from a liquid to a gas. That's interesting and a little different too. Let's look at it closer and see what we can come up with. I'll pour that in there. It should start boiling again. Yeah, it did. You notice it boils from the bottom because the bottom is kind of the hotter part, but this is really boiling from all angles. Put some of this more in there. People worry about me 300. I worry about myself some days more than I should. Not enough probably, but about this stuff. Will I freeze my fingers in there? And the truth of the matter is, yeah, if I held it in there. But the other truth is that it sort of bounces off me because it boils instantly on my skin. And I'm protected for a while. And I work quickly, and I don't use the heavy gloves because I end up spilling more when I do that. So let us think about this. Now here, what do we call these things? What do we call them? Bouncy balls? I'm not sure when we stop calling them super balls, but we call them bouncy balls. Let's put it in there and see what happens. Again, the heat from that ball is going into the cold liquid nitrogen. Now you can't put cold into anything. You can't. And I'm waiting for someone to go, oh, wait a minute, dude. I got a box in my kitchen that puts cold into itself and makes my food stay cold. You got a box in your kitchen that takes the heat out of things, like what's happening here. That's the only way the universe runs.
I know what that is. That's a freezer.
What is that?
A freezer.
That's a freezer. And we've got a bouncy ball giving up what heat it has, which was probably 70 degrees like the room, into the minus 321 degrees below zero liquid nitrogen. Where do you think we get this liquid nitrogen? Anybody wonder? Come on, crew, take a breath and think about it. Deep one. Where? It's a good try, but it's not correct. I suppose you could get it from up there, but anybody else? Take a deeper breath.
Maybe like a cryogenic freezer.
Okay. Okay. Next to the COVID vaccines? Yeah, okay. Pretty okay. You actually get it from the air, right? So this air that we breathe all the time is about 4/5 nitrogen, and if you squeeze it down and squeeze it down, it gets hot. It's going the wrong way. But we already know you can take heat off of things, so if you squeeze it, take heat off, squeeze it, take heat off, you end up with something liquid when you get it squeezed close enough, because it takes up a lot more space when it's a gas, and that doesn't act like it used to act. I wouldn't touch it yet. You could kick it back at me. So it's about 321 degrees below zero. And colder than it gets anywhere on Earth. And I know I shouldn't be doing this, I shouldn't be doing that. Ah! Okay, I got it again. So, how cold does it get on Earth? What's the coldest day that was ever recorded on Earth?
-7.
Not what negative, the colder now. What do you got? Where was it? You were right with the poles answer before. Did South Pole, yeah. A satellite measured minus 145 degrees below zero. So it doesn't get that cold on Earth naturally until we do it. All right, let's play with it a little bit just because, why not? So I'm going to say, for instance, I have this balloon here and I wanted to get it in here. What do you think I should do? Any ideas? It doesn't fit. Any ideas? What do you have?
You could pop it, then it would fit.
I would lose my last breath of fresh air, which I put in this before I became cynical. I want to hold on to that. How can I put that in there while retaining what's inside?
Squeeze it?
You guys need to attend these birthday parties more often, I say.
Sink it.
Sinking it in this cold liquid nitrogen and then put it in there. So sure enough, gases do change shape, which is what's in that balloon. It's my lung gas. I put that in there. I'll say that is. But it is changing shape quite quickly. And now it's stuck in there. The idea is how I can get it out.
Freeze it.
Pour some of the stuff in it.
Pour some of the wet stuff in there. Pour some of the Lycoponium powder in there.
Liquid nitrogen.
The nitrogen. Knowing all this stuff. All right, let's try that and see if we can pull that off. I should have enough here. And that jar is getting cold. I'm getting a new container. This one has a stick on it. All right, let's see if you guys had the right idea. Uh-oh. I don't know if your idea is going to work or not. I think I need some more of this. Whoa, 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 whoa. Sure enough. You guys are right. Boy. All right. What else should we look at? Oh, I know what I'd like to look at. Do this. Take this away. This was your cheat sheet, by the way, for those temperatures we were asking for earlier. I'll keep it right there in case you come out of that again. Ever hear about something called absolute zero? What's that about? It's even colder.
Is it the coldest that something can get?
It's the speed minimum of the universe in terms of heat, right? It's the coldest we think the universe can get. And the closest substance we have to that is liquid helium, of which we have a little bit of gaseous helium around here, but liquid helium is a highly coveted. All right, I'm going to put some of that in there. Any predictions? Oh, who knew that was coming? So you are in a fog of mostly water vapor and a little bit of nitrogen, which you breathe all the time, so that's not a problem for you.
Can you bring that over?
It looks like an explosion.
It does kind of look like an explosion. We might even have an explosion. What do you want me to do, Melly?
Z's never had it. No, I.
Shh, we've never done that to her? Oh. We won't do that to her. She doesn't want us to do it. Of course, that means you want to do it all the more, right?
I don't want it.
There, you've been indoctrinated. It kind of smells like a cold winter morning. Well, you can't smell it. If you smell it, it smells like a cold winter morning, I think. You sort of smell that. What else? Oh. I know what I want to show you. All right, what do we know about these things when they do that? What do we call that? What do we think? It's okay to be wrong. It's okay to think and be wrong.
Helium.
Helium balloons, right. Helium balloons float, right? Why? I mean, they do, but why?
Because they're lighter than air.
They're lighter than air. They're lighter than the air that they surround. Would helium balloons float in a helium room? No, they wouldn't. Well, we don't have a helium balloon. Well, we take it like this. All right, let's put this in here. So, we're going forward with the idea that helium balloons float, right? Seems pretty good. Very good plan. Makes us sound smart. How about we make a general rule? Helium balloons float. Is that a good rule? Maybe it is. Maybe it isn't. Helium balloons don't float. Help me out here. Rise. Work it up. Work it. Work it. Rise. All right. So maybe helium balloons float because we're magic, and they want us to be pleased by them. Or there's another explanation, which is helium balloons sometimes float. Why don't they always float? Maybe it's blue ones that do it. I have a in here full of helium. Let's see what that one floats. See if that one always floats. So the gas in this helium balloon is getting colder, but it's not getting liquidy. No, 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 no. That takes near absolute zero, another 100 degrees colder than we're having in this cooler. So helium balloons sometimes float. And the reason they don't always float is why? When they're colder, they don't seem to float. Why? Was it bigger when it was colder? It was actually smaller, and so it wasn't lighter than the same amount of air when it was smaller, only when it's full size. So helium balloons float when they have warm gas in them. When you put cold gas in them, they don't float. There! That's something.
But because the helium balloons do thing a lot of places at parties.
Well, we brought all our party favors along, and we've even got a cake over there, so we're going to see if we can't figure out something else here. We're going to move on to things that aren't so... Well, I haven't done this in, oh gosh, it's been a year or two. We'll see how I do. So, in my hand I have something called Lycoponium Powder, and it's not particularly flammable, only a little bit. But there's something about fire that we need to know, and we can learn from this stuff. This is actually the pollen of a ground pine plant. And it doesn't really burn unless you spread it out a little bit. And then why does it burn? I sense we should review the notion of combustion. So what do you need to get a fire going? And what was that lacking? You've got to have something that, what? Fuel. You've got to have a fuel, something that burns. You've got to have that. What else do you need? Fires breathe like we do. They need oxygen. No oxygen, no fire. How do you get that fire started? Heat. You've got to add heat to it. You've got to have those three things. And if you get all of those things going in a chain reaction, you get a fire that sustains itself. Remove any one and the fire goes out.
So why didn't the lycopodium burn when it was in his hand?
Because there was, what? You guys, I need a sprayer of water. Somebody give me a sprayer of water. A good sprayer of water. Why didn't it burn in my hand? Because it was packed in. There wasn't enough oxygen to get that thing started, to start that chain reaction, to get it going. So we always know that there's this, and that burned because that's got plenty of chain reaction going and plenty of heat moving through there. Let's try something else. Some things resist a change in temperature. Does anyone have a, you have $1? I can, and you're going to put your money in the show, you're going to put your skin in this game? All right, we'll do it. Let's try something. I'm going to pour this substance there. That fire was really, really exciting, wasn't it? Did it seem like it was a happy fire to you? Good golly. I'm going to move it back here. We have a flammable table. That's why I sort of don't like it. All right, let's go another one. So, you gave me your hard-earned dollar, and we pay you guys not at all. We don't even pay these guys. They show up to work 2 days a week. I don't know. We're either terrible or they're just great, or I don't know what it is. I think they miss school so bad that they work here for free. I think we double their salary. What is it? What is it?
We hate school. This is just fun.
You hate it. They hate us. They hate us. They hate this place. They always want to. They give us their money, buy us things, do the jobs we don't want to do sometimes. Oh my! And we go and burn their money, or do we? What happened? How come we didn't burn up? You know, you have all the answers. You always have all the answers.
Because it was burning whatever it was.
It was burning whatever, and then there was something else in there that wouldn't let it burn.
Yeah.
It burned up the alcohol, and the water that was behind wouldn't let it burn. Exactly, that's what happened. The water protected it, it kept it cool, and so only the alcohol, which has a higher vapor point, was burning, and the middle is kind of wet behind. Did you guys give me a sprayer? Oh, you gave me a sprayer. All right. Thank you. I was supposed to remember that. We're going to do something a little fun here. Do you guys have a... We're going to set this go. I'm putting a little bit of that alcohol in there, that rubbing alcohol. This stuff's a little bit more go. This is the 91%. That other stuff was 70%. We have this to go, just because it's fun. That's alcohol, right? Okay, so we've got a nice toasty little fire here. It's okay. Not my best fire, not my worst. But if we change something, what can we talk about? We can talk about how it changes. We have less fuel than we've ever had, but we've got more fire than we used to have. Why? Why?
Because it's being exposed to more oxygen?
Because we're actually creating a vacuum there and drawing more oxygen in, and we're seeing those swirls. That fire tornado are the swirls of airflow that are the sort of weather that's being created at the fire point. So, forest fires create their own weather, and that's what's actually happening here is we're creating a weather system. Now, when we want to put out a fire, what do we use? We use water, because water addresses all of these elements. It takes away the heat, smothers out the oxygen, and it makes the fuel less burnable. Yeah. All right, how's your cake doing?
It's coming.
You guys need more fire over there? Wouldn't be much of a birthday without a cake. So, your 7 is on here, but our 27 is on here too. So, bring in the cake. I'm going to pull this back. We're going to put the cake in front of the camera. And this is not the year you want to invest in birthday candles, because we believe, get your gadget. We believe that this is created some challenge for people for how to get the candles extinguished while keeping the cake. Remember, you got to pinch it. So in that balloon, there's helium. Helium's a noble gas. Nothing mixes with it. It should subtract the oxygen around these flames. We don't know. We did it on one candle for test. So we'll see how this works. Maybe it's great. Let it go. See what happens. You gotta twist it. So there's a safe way to blow out your candles at a birthday party. We had a backup gadget, which we did not need. And so there's that. We also make, you can pull the cake away. Stop staging me. Go. I've got one more thing I want to show you guys. This is not for the make it hard. Whenever my cameraman backs up, you wear it. We'll pull this back. We got the arm silverback gorilla here. I'm going to take his arm, put it into action. We're going to celebrate our birthday date with a bang, because that's just the way we do it around here. You guys give me a count back. I'll send this hydrogen balloon into the ethersphere. By the way, that helium that we put out the cake with went through the ceiling, through the roof, through the atmosphere, and it's going to outer space. I mean, we can't even keep that stuff on Earth. It was discovered on the sun. There we go. Keep my eyeballs. So I'm going to set this go. But you guys are going to give me a 5, 4, 3, 2, 1 combustion.
5, 4,
3, 2, 1.
I'm not inspired. 5, 4, 3, 2, 1. Happy birthday.